So I'm here with Mihkel Pajusalu, who is a planetary scientist at Tartu Observatory, and he's holding in his hand a instrument that is being built here at the observatory that will be included on the ESA Comet Interceptor mission, which is due to launch when is it due to launch?
The mission is currently due to launch in 2029, so in a few years.
And what is the goal of the mission and this instrument?
The goal of the mission is to fly past a pristine comet that would be entering the inner solar system for the first time. This camera that I'm holding in my hand currently, this one is going to be on one of the probes that will be launched very close to the nucleus of the comet.
So it's basically three parts of the mission. You're going to have a flyby, which is the main spacecraft, one probe that's going to go to the nucleus with the instrument that you're holding, and then another probe that's going to go to another part of the nucleus. Is that right?
Well, all of them are doing flybys technically, just this would be on the closest probe, the probe that is going to fly by the closest to the nucleus. So this is going to be around 400 kilometers from the nucleus, and this is going to take photos from that distance.
And so how will you, number one, determine that the comet that you're observing is a pristine comet? Because interestingly enough, you're launching to the gravitational Lagrangian point 2, which is a stable gravitational point in the Earth-Sun system. And that's where you're going to hang out potentially as long as 5 years before you acquire a target. That's unheard of in space missions, if I'm not incorrect.
Yes, this is a relatively novel concept. So in this case, the mission has its own dedicated target selection team that will analyze the orbits of different detected comets and basically determining where those comets are coming from. You can determine that they are coming from areas where they must have to be pristine.
And heretofore, we've only been able to study comets that were not pristine.
Yes, the comet studies thus far have mostly been modified by the Sun. So this will be the first close flyby and imaging of an unmodified cometary nucleus that has been unmodified since it basically formed when the solar system was forming.
And why is this important?
It is important to see the conditions that were in the solar system before the emergence of life and before the planets were formed. And this would tell us actually what the conditions were and how this affects our models about the emergence of life on Earth. And
I couldn't let this one go. You happened to mention, and I was totally, had no idea. This is this observatory used to be active during the Cold War, when the Soviets, when this was actually a Soviet republic, Estonia, and it developed a lot of the space technology used during the Soviet space program. Is that correct?
Yes. To my knowledge, all of the Soviet space stations, all the civilian ones, had some kind of instrument that was developed in here on board.
And then in the 90s, this observatory kind of drifted a bit, and now since 2000s, you are back designing instruments and involved in space missions in a big way.
Yes, so there was long term in the 90s and early 2000s when there was very little space activity, but we started to pick it up around 2008, and then 2015 already we joined the European Space Agency, and now it's really picking up. So there are many space companies now, and it's the first Western instrument for a Western space mission from Estonia.
Well, congratulations, and Mihkel, thank you so much for your time today.
Thank you.